All right, if you are watching this video, it's because you have nothing at the corner of your packet, which is totally my bad. It might say Bruce on the page, but here we go. We are going to do area of complex shapes. We're not actually going to do this as a lesson this year. This is something you need to know for 7th grade. It's a little bit of a review from last year. You may and probably will see problems like it on the park test, so take this seriously. It's totally within your realm of being able to do it. So I have this complex shape, for example, 1, and I want to find the area of it. Now, this is not just like a rectangle, parallelogram, it's a bunch of different shapes. So I need to cut this into 2 shapes so I can figure out how to find the area of it. There's 2 options. I could make it a rectangle and a rectangle, or I could make it this rectangle and a longer rectangle. It's up to you how you do it. I'm just going to leave it like this. But both ways are possible. So I'm actually going to draw that line in, and I'm going to find the area of both of these rectangles, and if I add them together, it's the total area of the shape. So I'm thinking, I see this rectangle, I want to know the area of it. I can't just do 4 times 6. That doesn't work because 6 feet only goes to right here. So I know that the width is 4 feet, but I want to know what this entire length is. Well, if to here is 6 feet, what would this last space here be? I see that up here it's 3 feet, so that makes me assume that this is also 3 feet. So if this is 6 feet to here, and here to here is 3 feet. Together, 6 plus 3, this entire this entire length is 9 feet. So then I can use this information to find the area of this rectangle. Just this rectangle here would be the length of 9 times the width of 4. 9 times 4 is 36 square feet. That's the area of this shape. I want to find this shape and then add the 2 together. Similar thing, I know here that my width is 3. This length of 8 feet is this entire length here. I don't want to know this entire length. I just want to know from here to here. So I'm going to move this over. You can't necessarily do it on your packet, but I'm going to say that all of this is 8 feet. I want to know just this chunk here. Well, I know I can look around. I see that right here, this length is 4 feet, which tells me this length is 4 feet. So this length's 4 feet. 4 feet plus what here would make the entire thing 8 feet. If this is 4 feet, then this also has to be 4 feet. Because together, 4 feet plus 4 feet makes 8 feet. So I know my width of 4 feet and my length of 3 feet. 4 times 3, I find the area is 12. Now, apart, these don't give me very much information, but I know if this rectangle is 12 feet and this rectangle is 36 feet. 36 plus 12 together, it's 48 square feet. I could fit 48 tiny little squares into that very strangely shaped object. That's example 1. We're going to move over for example 2. So come along with me. How's it going? Fantastic. All right, here's example 2. We want to find the area of this shape. Let me make sure I got the whole thing on there. Area of this shape. This shape is not necessarily looking like that one. I want to see if I can find 2 shapes in it. I could draw a line right here, but then I have this super funky shape. I don't really want to work with that. I'm going to draw my line right here. If I draw a line here, I have a triangle and I have a rectangle. I know how to find the area of both a triangle and a rectangle, so it works perfectly. I'm going to start with my rectangle, easier. I want to do length times width because that's how I find the area. I see a 12, 3, and 9. The length is the entire distance, so I'm going to pick the 12, not the 9, because the 9 only goes to here. So 12 times 3, well, I know 10 times 3 is 30, and 2 times 3 is 6. So this would be 30 plus 6, 36 centimeters squared. Now I have my triangle. A little bit harder, but it'll be fine. I want to know the distance of my base and my height. Right now, I don't know either. So I need to look at other things around it to see if that can help me. I know this entire length is 12, and this length here is 3. Or sorry, this length here is 9. So if up to here is 9, how much more would I have to add right here to make the entire length 12? Well, 9 plus I gave it away 3 equals this length of 12. And I know that this length and this length of my rectangle are the same. So that makes my base of my triangle, and I'm just going to write it, my base is 3 centimeters. Now I need to find the height. 8 centimeters is this entire length here. I just want to know here to here. Well, the whole thing is 8. I'm going to look around. I see that this length here is 3, which means that this length here is also going to be 3. So right here, this is 3 centimeters because it matches the other side. These are the same. Well, if this is 3 and the entire thing is 8, 3 plus what number would get me to 8? That would be 5. So I know that the height of the triangle is 5 centimeters. Now I need to find the area of my triangle. Area is, and if you don't remember the formula, think about it. A triangle is half of a rectangle or a square. So if I drew half of a rectangle, well, the area of the rectangle would be 3 times 5. But I'm not looking for a rectangle, I'm looking for a triangle. So I have to do 3 times 5, and then I have to divide it by 2. So 3 times 5 is 15. And now because it's a triangle, I have to divide by 2. 15 divided by 2. 2 goes into 15 7 times. 1 left over. I can bring it up as a fraction or make it a decimal. I prefer fraction. So it's 7.5 centimeters squared. That's my triangle. This is my rectangle. Add the 2 together. 36. And now I'm going to have to do 7.5 as a decimal, 7.5. 43.5 centimeters squared. Pretty cool stuff. You have the rest of the packet. The last page is a problem from the example park test. Good luck.